Okay, welcome. This is 13.2 applications in business and economics. We're going to look at consumers and producers surplus models that involve integrals. So with all this, there's a big old paragraph. Let P equal D of X be the price demand equation for a product where X is the number of units of the product that consumers will purchase at a price of price P per unit. Suppose that P bar is the current price and X bar is the number of units that can be sold at that price. If the price is higher than P bar, the demand X is less than X bar. But some consumers are still willing to pay the higher price. Consumers who are willing to pay more than P bar, but who are still able to buy the product at P bar, have saved money. So let's say your new TV you want is $2,000. It goes on sale for $1,500, but you still have the money to buy it for $2,000. So you're still able to buy it for $2,000, but now you'll buy it for $1,500, which means you will save money. Okay, we want to determine the total amount saved by all the consumers who are willing to pay a price higher than P bar for the product. So the consumer surplus integral will show us or tell us how much money we as the consumer will save if we are the person who has X amount of money to buy it, but can buy it at a lower price. So we'll see how much we save. The consumer surplus, if X bar P bar is a point on the graph of the price demand equation, P equals D of X for a particular product, then the consumer surplus CS at a price level of P bar is consumer surplus equals the integral from 0 to X bar of dx minus P bar dx, which is the area between P bar and dx from X equals 0 to X bar. The consumer surplus represents the total savings to consumers who are willing to pay more than P bar for the product, but are still able to buy the product for P bar. All right, so example 1. Find the consumer surplus at a price level of P bar equals 8 for the price demand equation, P equals D of X equals 20 minus 0.05X. Find the value of X bar. Okay, so that's our first step. We want to find X bar. We're given P bar, so we want to find X bar before we move on. So to do that, we let P bar equal D of X bar and solve for X bar. And we will state the answer as a coordinate, X bar, P bar. Okay, so that's our first step. All right. So right here, step 1. So we're going to do step 1, which means that we're going to let P bar equal D X bar, which will then become 20 minus 0.05 X bar. 20 minus 0.05 X bar. Now, what we know is that P bar is actually equal to 8. That's given in the problem. So we're going to plug that in for P bar. So this becomes 8 equal to 20 minus 0.05 X bar. And all we have to do is solve for X bar. So subtract 20 to the left, you'll get negative 12 equals negative 0.05 X bar. Negative 12 equals negative 0.05 X bar. Then divide by negative 0.05. Divide by negative 0.05. And 12 divide 0.05 gives me 240. So 240 equals X bar. This means that our point which we need to state as a coordinate, is going to be, so the point we state it as, I'll write it, x bar, p bar is going to become 240, comma 8. Okay. Next is to sketch a graph of d of x. So we're going to make an XY chart, right? Or it could be a x bar, p bar chart, whichever you like. We'll keep it simple, we'll just say XY. Okay. All right. So 2. We're going to sketch the graph of d of x. So I'll rewrite d of x. D of x is 20 minus 0.05x. And I'll make my XY chart. Okay, so one of our x values given is 240. Another x value given is 0. That comes from the consumer surplus integral above. And it makes sense, if we're selling something, we can't go below 0. So our numbers should go from 0 to 240. But I'll add a little more information in there. So 0 to x bar, 0 to 240 is our interval. But again, let me just add some information in there, just so we get a whole graph. So 0 is where we're going to start at. So we're going to say 0, and since my x bar value is 240, let's go by 100s. So I'll say 0, 100, 200. Let me sneak the x bar value in there, 240, then 300, 400. Okay. And if we need more, we can add more. Let's try 500. There. That's where we'll stop. We don't need any more than that. Okay. We'll do 500. Okay. Now I'm going to plug d of x into my calculator, into the table feature. Table function 20 minus 0.05x. Enter, 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 enter. Can clear these values out to make room, and then type in 0, you get 20. So 0 gives me 20. Type in 100, you get 15. 200, 10. My 240, which will prove that our p-bar is 8, gives me 8. That's what p-bar is. 8. 300, 5. And then 400 gives me 0. So we can actually stop here because price can't go below 0. So our y value, our p-bar value can't go below 0. Because if I type in 500, I get -5, and we don't need those values. We don't need anything that's going to be negative. Okay, so let's come to the graph and plot. Okay, so for my x values, I start at 0. I can probably skip around too. So this will be 0, 100, 200, 300, 400. And then for my y values, we go up to 20. So let's just go by 5s. Here's 5, 10, 15, 20. Okay, and let's graph. All right, so when x is 0, y is at 20. So right there. And then when x is at 100, we are at 15. Right there. When 200, we're at 10. 240, somewhere around there, we're at 8. So you just put it like right there, sure. And then 300, we're at 5. And then 400, we're at 0. That's a little off, but whatever. Okay. Then connect. There's our graph. And then what we want to show is what we see in the graph above, the actual X bar, P bar point, which will give us the consumer surplus area. So we have our point at 240 and 8. 240 and 8. So this will be 240. And then 8, I'll put around here. So there's that. And now the consumer surplus, this is the area we're trying to find. Right here. This is the consumer surplus. Okay, perfect. It's graphed. That's done and over with. Now 3, set up the consumer surplus integral. Let's move on. All right. So 3. My consumer surplus is going to go from the integral of 0 to x bar, and our x bar value here is 240, of dx, which is 20 minus 0.05x minus p bar, which is 8 dx. Okay. This means we get from 0 to 240 of, and you can do the 20 and the 8, so you'll get 12 minus 0.0, no, yeah, 12 minus 0.05 x dx. 12 minus 0.05 dx. Now find the antiderivative, which means this becomes 12x minus 0.05 x squared over 2 evaluated from 0 to 240. All right. Now type that in. I mean, I can make it look pretty. I assume you're pretty good at the calculator by now and have the answer already. So if I want to make this look pretty, I would make this 12x minus whatever 0.05 over 2 is, and that's 0.025 x squared evaluated from 0 to 240. Okay, let's type it in, and I'll get that my consumer surplus. So if I do, so I'll do it the long way, right? Here's the long way. Type it in the table. 12x minus 0.025x squared. Enter, enter, enter. Type in 240. Type in 0. We get 1440. This means that consumers will save $1,440 on this product. That they have the money to buy at normal price, but will buy the product at the discounted price, at a lower price. Okay, that's it. Now again, shortcut, let's see. Second integral 0 to 240 of 12 minus 0.05x. Enter, 1440. Boom, beautiful. There it is. Okay, that was consumer surplus. Next is producer's surplus. Let me check my messages. Okay, if P equals S of X is the price supply equation for a product, P bar is the current price and X bar is the current supply, then some suppliers are still willing to supply some units at a lower price than P bar. The additional money that these suppliers gain from the higher price is called the producer surplus, PS, and can be expressed in terms of a definite integral. So say we give X amount of items to one store for $10, and then we give X amount of items to another store for like $8. So in the end, we still make money because we have it higher at another store. So that's like producer surplus. So we still gain money from the higher price. Okay, so producer surplus, if X bar, P bar is a point on the graph of the price supply equation, P equals S of X, then the producer surplus, PS, at a price level of P bar is given as producer surplus equals the integral from 0 to X bar of P bar minus S of X dx, which is the area between P bar and S of X from 0 to X bar. The producer surplus represents the total gain to producers who are willing to supply units at a lower price than P bar, but are still able to supply units at regular price, P bar. So there you go. So 2, find the producer surplus at a price level of P bar equals 20 for the price supply equation, P equals S of X plus 5 plus 0.1x plus 0.003x squared. Find X bar. Okay, excellent. So this is gonna be just like last time, we're gonna find X bar. So we're gonna set P bar equal to X bar. All right. Actually, I think 20 is the wrong number to work with. So I'm going to pause for a second. I didn't pause. I did stop share. Ah. Okay, I'm back. I fixed the problem. It was totally botched, but now it's better. Okay, so find the producer surplus at a price level of P bar equals 62 for the price supply equation. P equals S of X equals 15 plus 0.1x plus 0.0003x squared. Find X bar. Much better. Okay, cool. So just like we've been doing, let's find X bar. So step one. Okay. So we're finding X bar, so we let P bar equal S of X bar, which will give me 15 plus 0.1 X bar plus 0.0003 X bar squared. 3x bars squared. Okay, maybe I can zoom in a bit for you. There you go. Okay, and now we know that P bar is 62. So let's plug that in. So we get 62 equal to 15 plus 0.1 X bar plus 0.0003 X bar squared. Okay, well, since this is X squared, this is a quadratic equation, which means 0 needs to be on one side. So this means we're going to move 62 over. So I'm going to take 62 and subtract it, right? So I would get, so say minus 62 minus 62 right there, right? All right. So you get 0 equals, and I'm going to rewrite this with the highest power first, which is X bar squared. So 0.0003 X bar squared plus 0.1 X bar, and 15 minus 62, negative 47, minus 47. Okay, so now 2 ways to solve for X. Factor it, which we're not going to do, or quadratic formula, which, yes, that's much better, right? We're going to quadratic formula this. So we quadratic formula. I'm going to label everything I have. And here, A is 0.0003. B is 0.1. C is negative 47. Now take this and quadratic formula. We're going to say X bar is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. That's your quadratic formula, right? Which means we now know what to plug in. So x bar equals negative 0.1 plus or minus the square root of 0.1 squared minus 4 times a, which is 0.0003 times c, which is negative 47. All over 2a. So 2 times 0.0003. Okay, let's calculate. So first we write this as x bar equals negative 0.1 plus or minus. And now I'm going to type this whole square root in. Watch this. Second square root 0.1 squared minus 4 times 0.0003 times negative 47. Enter. That's it. I'll do this to what? 2 places? Sure. 0.26. 0.26 over 2 times 0.0003. 0.0006. Okay, here we go. 2 choices, plus or minus route. Let's go the plus route. Negative 0.1 plus 0.26 over 0.006. So let's see what I get. Oh, you can type that whole thing in. Negative 0.1 plus 0.26 over 0.0006. I get 266.67. Okay. Then try the minus route, which I don't think we'll need. Negative 0.1 minus 0.26 over 0.006. So I'll just take the same thing from above and subtract. And I get negative 600. Well, remember, x is demand here. So can we use negative demand? No. So this is out. This is our x bar. And I guess since it's demand, we can't have 0.67 demand. So let's round up to 267. Let's do the 267. Okay, and now, with all this being said, we now have our x bar, p bar. It's going to be 267 and 62. There you go. That's x bar, p bar. Okay. Terrible, right? I know. All right. Purely algebraic, though. Okay. So next, we want to graph it. Sketch the graph. So again, let's make an XY chart. So here's step 2. So S of X is 15 plus 0.1x plus 0.0003x squared. And for my XY chart, again, for these problems, we'll always start at 0. And then my X bar is 267. So again, let's just go by 100s. 100, 200. Let me sneak 267 in there. 300, 400, 500. Okay. And now I'm going to type this in my calculator to the table feature. Clear that out. Put in S of X, 15 plus 0.1x plus 0.0003 x squared. Enter. Enter. All right. Type in 0, I get 15. Type in 100, I get 28. Type in 200, 47. Type in our 267, and we get 63. So, I mean, if I type in 266.67, then we get 63 still. What if I typed in 266? We get 62, so around there. Okay, I mean, I did cut off a lot of decimals on that square root, so as long as we're in that area. So 267 should be around our 62. And then 300, 72, 400, 103, and we can stop at 500. 140. Doesn't look like we're getting anywhere near negative numbers, so we can stop at 500. Okay, let's make my XY chart appropriate. All right, so with that being said, 0, 100, 200, 300, 400, 500. Now for my XY values, we go up to basically 100. So 15, 28, we can go by 20s. I don't think I can skip 20, 40, 60, 80, 100. I mean, if we keep the 500 out, we can do it. We don't need the 500, it's just there. So let's do it. We'll say 20, 40, 60, 80, 100. And I know we go to 103, but whatever. This is just a sketch. Okay. Let's graph. And 0, we're at 15, so that's 10. So put it around there. 0, we're at 15. 100, we are at 28. Put it around there. 200, we are at 47. Somewhere around there. And then sneak in our value of 267, we're at 62. So 267 this will be my that's our X bar P bar. So that's why I changed the color. Okay, then 300, we're at 72. Something like that. 400, we're at 103. That's a big jump, right? 72 to 103. So there we go. Okay, here's what our graph looks like. It's definitely curvy. Okay. So here at 267, and 62, we get our X bar P bar right there. Okay, which means we are looking for this area. That's the producer surplus. All right. Okay, now all we have to do is set up the definite integral. Okay. The producer surplus integral, sorry. All right. So our producer surplus is going to be the integral from 0 to 267. From 0 to 267, and it's going to be P bar. So 62 minus S of x, which is 15 plus 0.1x plus 0.0003x squared dx. Okay. Cleanup. 0 to 267 of, so that negative has to distribute. So 62 minus 15, you'll get your 47. So we'll get 47 minus 0.1x minus 0.0003x squared dx. So all the signs change. Okay. All right. And then you're ready for the antiderivative. So we'll get 47x minus 0.1x squared over 2 minus 0.0003 x cubed over 3 evaluated from 0 to 267. From 0 to 267. Okay, so can't really make that one look pretty, so let's just go ahead and calculate. All right, so if I do table clear, what do I have? 47x minus, this becomes 0. Actually, yeah, 0.1 over 2x squared minus 0.0003 over 3x cubed. And all I have to do is type in 267, and I get $7,081.13. So this is what the producers gain if they still have their item at normal price, and even if they have an item at discounted price, they still make money. So this is what the producers will gain. Okay, quick check, right? Second integral 0 to 267. Oops. Of, what do I have? 47 minus 0.1x minus 0.0003x squared. Enter. $7,081.13. Perfect. Whew. All right. Last one. All right. In a free competitive market, the price of a product is determined by the relationship between supply and demand. If P equals D of X and P equals S of X are the price, demand, and price supply equations, respectively, for a product, and if X bar P bar is the point of intersection of these equations, then P bar is called the equilibrium price and X bar is called the equilibrium quantity. If the price stabilizes at the equilibrium price P bar, then this is the price level that will determine both consumer surplus and producer surplus. Okay, so we're looking for equilibrium price and equilibrium quantity. Find the equilibrium price and then find the consumer surplus and producer surplus at the equilibrium price level if P equals D of X equals 39 minus 0.05x and P equals S of X equal to 15 plus 0.05x. Find the equilibrium quantity and equilibrium price. So the first thing we're going to do is take D of X and set it equal to S of X and solve for X. This will give us X bar, the equilibrium quantity. So that's what we're going to do first. All right, we're going to say find X bar. So to find X bar, you take D of X and set it equal to S of X. All right, what's D of X? D of X is 39 minus 0.05x equal to, what is s of x? 15 plus 0.05x. So 15 plus 0.05x. 15 plus 0.05x. Okay, perfect. Okay, now all we have to do is solve for x. So with that being said, I will move x to the left and 39 to the right. So say minus 0.05x minus 0.05x, and then same move, I'll say minus 39 minus 39. We'll get negative 0.10x, right? That's negative 5 cents minus 5 cents, so that's negative 10 cents, equal to 15 minus 39, what's that, 24? Negative 24. Then divide by negative 0.10. And 24 over 0.10 should be 240. Yep. So x is 240, which means that this becomes x bar. So this means that x bar is 240. All right. 2, find p bar. So we're going to look for p bar. So I'll do that here. 2. Find p bar. And to find p bar, take x bar and plug it into an equation of your choice. You can plug it into d of x, or you can plug it into s of x, and you're going to get the same answer. The reason we get the same answer is because both functions intersect, and at the point where they intersect, they are equivalent. So this is why it does not matter which one you choose. So I'll just plug it into d of x. So I'll say d of our new x value of 240 equals 39 minus 0.05 times 240. And we'll get 39 minus 0.05 times 240 gives me 27. This is now our p bar. So this means p bar is equal to 27. Which means together we have our point, x bar, p bar. We have 240 and 27. This is x bar, p bar. Okay, 3 says to sketch a graph of both d of x and s of x. Okay, oh yeah, and to show you how it will work no matter what, in whichever function, let's say I chose s of x. I would say 15 plus 0.05 times 240 and we still get 27. Okay. All right, excellent. So let's go ahead and graph S of x and D of x. So this is 3, so we need XY charts for both. Where can I put them? I could probably fit them up here. Let's try to fit them in this top corner up here. All right. So 3. Graph f of x and d of x. Let me zoom in for you. Okay, so 3, you have that d of x is 39 and 0.05x. 39 and 0.05x. And for my XY chart, here's what we're going to choose. We start at 0, and our X bar is 240. So we'll have 0, 100, 200, 240, 300, 400. Why not? I don't think we'll need a 500. And then same thing. S of x is 15 plus 0.05x. And we'll choose the same values for my XY chart. 0, 100, 200, 240, 300, 400. Okay. And the beauty of this calculator, it allows me to type in both functions. Watch this. 39 minus 0.05x, enter. 15 plus 0.05x, enter. Ooh, 2 XY charts, love it. So I type in 0, and for the first one I get 39. For the next one I get 15. Type in 100, it's already there. I get 34, and I get 20. Type in 200, I get 29, and I get 25. And then type in 240, we know what we get there. We both get 27, because that's our equilibrium point. Then type in 300 and 400. There we go. Speed that up a bit. 24 and 27. Right, 24 and 19. And then here I got for 300, I get 30 and 35. That's perfect. I think that's all we need. Okay, let's graph. So once again, 0, 100, 200, 300, 400. All right. Y values, what do we have? 39, 34, 27, 24, 19, 15, 20, 25, 27, 30. Let's just go by 5s. The highest is 39. That's fine. We can't skip around, right? 5, 10, 15, no. So this will be 5, 10, 15, 20, 25, 30, 35, 40. Okay. Now graphing. I'll keep them the same colors. All right. So 0 and 39 is for the first function, so probably right around there. 134, right there. 229, right there. 240 and 27, so put that right around here. I'll make that a special color because that's our equilibrium point. So 240 and 27. Something like that. Okay. And then 324 right there. And then 419. Okay. Connect. Somewhat straight, right? You get the point. So there is d of x. Okay, now let's graph s of x. 0 and 15. And then 120. 225. 240 and 27, which is our special point right there. And then 330. And then 435. Okay, connect. So right where they intersect is our equilibrium point. That's our x bar p bar, which is the 240 and 27. $240 and 27. Okay. And labeling stuff still. This is s of x. And let's see. All of this is the area we're trying to find. So d of x is for consumer surplus. So this part is for the consumer surplus. And this part is for the producer surplus. So many colors going on. It's great. Okay, there it is. It is graphed. Yeehaw. Now we've made it to 3 and 4. Find the consumer surplus and find the producer surplus. So you have enough room. Perfect. Okay. So 1, 2, 3, well, this will be 4. Consumer surplus is going to be the integral from 0 to x bar, which is 240. And if you forgot the consumer surplus integral like I did, it's going to be d of x minus p bar. Okay. D of x minus p bar. So d of x is 39 minus 0.05x minus p bar, which is 27 dx. Okay, clean up. The integral from 0 to 240 of 39 minus 27, is that 12? Of 12 minus 0.05x dx. And I'm sure you know how to do antiderivatives by now, so I'm just going to do this. 0 to 240 of 12 minus 0.05x. We get 1440. Yeah. This is the consumer surplus, right? This is what consumers will save. All right. Was that exactly like the first problem? Oh, close. Weird how we get the same numbers. It still became 12. Oh, super weird. Okay. And then 5. Producer surplus, which is from 0 to 240 as well, which means producer surplus was P bar minus S of X. So our P bar was 27 minus S of X, which is 15 plus 0.05x dx. Make it look pretty. The integral from 0 to 240 of 27 minus 15, that's 12. So weird. 12 minus 0.05x dx. Okay. Integral 0 to 240 of 12 minus 0.05x. Enter. Weird. Maybe that's why it's equilibrium. 39 minus, so you still end up with the same antiderivative. 1440. Huh. Weird. So we're at 240, making sure I got everything right. 27 minus 15 minus that. Now it's 39 minus 0. So it's 39. Yeah. Okay. Maybe that's why it's called equilibrium for a reason, right? So if the price is stabilized, then this will determine the consumer surplus and producer surplus. So if it's an equilibrium point, which means they're equal, Consumers save $14.40 and producers still gain $14.40. So, win-win. Not bad. Okay, that is 13.2. Yeehaw. Okay, that is all.